Welcome to today's Explainer. All right, so today we are unraveling a massive mystery, one that's literally keeping engineering leaders up at night all over the world. Look, AI coding tools are amazing, right? They're delivering these incredible productivity boosts, but they are also causing technology budgets to absolutely explode. So we're going to look at exactly why this is happening, where all that money is actually going, and how the smartest companies are reeling in their costs without sacrificing a single ounce of developer speed.
Okay, let's dive right into this with a number that should make literally any CFO sweat. 4 months. Yep, just 4 months. A recent case study revealed that Uber, a massive organization with a $3.4 billion R&D budget, they completely burned through their entire 2026 AI budget in just 4 short months. Adoption of these AI coding tools just exploded, way faster than anyone predicted, rocketing from 32% of engineers to 95% in a matter of weeks. The tool worked brilliantly, for sure, but man, the budget totally broke.
And honestly, that brings us to the core mindset flaw causing this massive financial drain. It's basically like treating a taxi meter like a flat-rate subscription. Think about it. When you buy a standard software license, your cost is fixed, right? Doesn't matter how much the employee uses it. But AI coding agents, they're a whole different beast. They consume variable compute tokens with every single action. When you take that unpredictable, completely unbounded meter and mistakenly treat it like a predictable $20 a month SaaS seat, well, you're just setting yourself up for a massive billing shock.
So let's start the investigation. Where exactly do all these tokens go?
With power users suddenly racking up agentic workflow bills of anywhere from $500 to over $2,000 a month, we really need to figure out the mechanics of this massive spend. And when we actually look at the token usage, the sheer scale of inefficiency is kind of wild. A recent dev community study found that a staggering 70% of coding agent tokens are just entirely wasted. I mean, they aren't generating brilliant new features. Instead, those tokens are being burned on agents endlessly reading files, searching through tangled codebases, and constantly reloading context. Basically, every time an agent has to reread your entire messy codebase just to understand a single function, you're paying for all that context again and again.
And, the problem is really compounded by human behavior. Research shows that roughly 60% of developers just stick to one primary model and never bother changing it. That means a super simple command like fix typo is currently being sent to the exact same incredibly expensive top-tier frontier model as a highly complex prompt like refactor architecture across 5 files. You are essentially hiring a senior staff engineer at a premium hourly rate just to fix a spelling mistake. It's crazy.
Which brings us to part 2, the smart routing solution.
Dynamic request routing is quickly emerging as the absolute master key to outsmarting all this waste. It drastically lowers costs without losing any developer productivity. Tools like AutoClaw seamlessly map incoming prompts to specific model tiers behind the scenes. So simple tasks like typos or quick factual questions are routed instantly to fast, cheap models like Minimax. But complex reasoning tasks like full architecture design are escalated to those top-tier models like Claude Opus. By reserving premium models only for genuinely difficult tasks, organizations are cutting their AI costs by up to 70%. That's a huge deal. Now, you might be wondering, how on earth does the system know which tier to use before it even runs the prompt? We'll take Cursor Router, for example. It uses this incredible sub-millisecond classifier that instantly evaluates 4 key things. It looks at the literal query content, the size of the surrounding code context, the inherent complexity of the task, and the specific domain. Like, hey, does this touch highly sensitive security code? It calculates all of this in literally a fraction of a millisecond to predict the absolute cheapest capable model for your prompt. It entirely removes that decision burden from the developer. And this brilliantly illustrates the next evolution in this space, the hybrid model harness. Take Cognition's DevInfusion, for example. Instead of one giant model doing every little thing, it actually runs a main frontier agent alongside a smaller, cheaper sidekick agent at the exact same time. The expensive frontier model, it handles the high-level planning and the final review. Meanwhile, it actively delegates all the repetitive, purely mechanical coding work down to the sidekick. This kind of independent context caching and delegation slashes costs by up to 62%, and it does it without sacrificing a single line of code correctness. It's literally like having a master architect and an apprentice working together seamlessly. So, what's next? Let's get into part 3, advanced optimization with telemetry and batching.
You see, most routers start out rule-based, right? They just follow fixed logic that someone actually has to manually update whenever prices change or new models launch. But learned routing, like the system built by Ramp, uses live telemetry data. It uses something called a Thompson sampling approach, which essentially treats each model like a bet. It tracks how well models are actually performing on live traffic and then automatically shifts requests toward whichever model is currently winning the cost-to-quality ratio. And it does all of this completely without human intervention. It's just continuously optimizing itself in the background. And academic research is pushing this even further. The recent Robatch paper reveals what happens when you combine that dynamic model assignment we just talked about with query batching. Normally, even with a smart router, you still end up paying the massive fixed cost of a system prompt every single time you query the model. It adds up incredibly fast. But by batching multiple queries into a single invocation after routing them, you can finally amortize that heavy system prompt cost across multiple tasks. It's a real game changer because it's optimizing both the model assignment and how the queries are grouped at the exact same time.
All right, let's bring it all together in Part 4, the Cost and ROI Playbook.
Based on Databricks' extensive research into digital native companies like Stripe, Coinbase, and Uber, we now have 4 absolutely critical cost levers to tame these wild bills while fiercely protecting your ROI. Number 1, move routine work to lower cost or open models. Number 2, implement dynamic task routing so the system chooses the model, not the user. Number 3, give your developers visibility through budgets and tripwires. And finally, number 4, reduce token overhead by actually keeping your codebase clean, so agents aren't forced to ingest massive amounts of unnecessary context. The overarching goal here, you want to constantly chase the efficiency frontier, rather than just blindly defaulting to the most expensive intelligence frontier.
So the crucial point here is exactly how you handle that budgeting. You might be thinking, hey, the answer is just to give everyone a hard monthly spending limit and shut off their access when they hit it, right? Actually, scratch that. Hard cutoffs completely kill productivity. Think about it. The developers spending the most are often your 10x engineers producing immense output. Instead, managers should use per engineer budgets as tripwires. When an engineer hits a threshold, it just triggers a review. This helps you separate high-value output, like a massive, complex multi-file refactor, from wasteful prompt churn, where maybe someone is just blindly reprompting an agent over and over without even reading the code.
Which leaves us with one final, absolutely vital question to ask about your own organization's setup. Are you buying AI like a predictable SaaS subscription, or are you actively optimizing it like the unbounded compute meter it truly is? Because if you don't have routing, telemetry, and tripwires in place right now, you are likely leaving massive amounts of money on the table. It might just be time to take a serious look under the hood of your own AI infrastructure. Thanks for joining me on this explainer, and keep optimizing.